Hello friends, today I shall talk about the project Optimal Ambulance Allocation. This is a early data science project I did in 2013 with Hyderabad EMRI. So I will give a brief introduction of the project, then I will talk about the simulation model, then I will talk about the data, and then finally I will present the analysis and the result. To give the introduction, our client was an emergency response management organization who handles medical, police and fire emergency through the 108 emergency service in Hyderabad. Now currently, I am talking about 2013, the organization runs 690 ambulances in AP across 223 districts. The live data input is fed to the simulation model to propose an optimal ambulance allocation, providing an opportunity to cost reduction for the organization. So this was a proposal that came out from the project. So to simulate, I have to simulate two distributions. One is the inter-arrival time of the calls, how the calls are coming, what is the inter-arrival time, and the service time of the ambulances from the start to come back to base, that is the service time. So there are two exponential models used in the simulation, and to talk about the exponential distribution, it is fx lambda is lambda to the power minus lambda x when x is non-negative and 0 when x is less than 0, and the mean of the distribution is 1 by lambda. So I just need to equate 1 by lambda to the average of the distribution to fit the model. How to do the simulation? If we look at the distribution function of the exponential distribution, fx lambda equal to 1 minus e to the power minus lambda x, the inverse distribution function f inverse p is minus log 1 minus p by lambda. So given a random number between 0 to 1, that is p, given an input to p, we get a sample from the exponential distribution with that proper lambda. So that's the way the models are simulated. And I have the number of I use the number of iterations 100, which is configurable. Number of calls is 10,000, which is configurable. Then average call inter-arrival time, which is estimated from the data, percentage of call received by the various district estimated from data, number of ambulances available in each district obtained from data, average service time for the ambulances across all districts estimated from data. And here is a little correction factor that is configurable, but 25% is an ad hoc number, which shows when an ambulance base doesn't have any ambulance left for a new call, what is the percentage extra we need to give to the service time to get an ambulance from a neighboring base. So but that's configurable in the simulation. So as in the output of the model, we get total waiting time considering all districts together. What is the waiting time of the ambulances for a call? Average waiting time per call, total waiting time for each district, average waiting time per call for each district, and number of calls received by each district. Okay, so we took 33,000 random samples, random sample of closed cases between April 1st, 2012 and March 31st, 2013 from AP, and this is the SQL to extract the call data, and this is the SQL to extract the ambulance data. And here are the call counts over the districts, and the total number of call in a month was 94,412. So considering 30 days in a month, we get the inter-arrival time of the calls. The average inter-arrival time of the calls is 0.46 minutes. So that's our 1 by lambda to fit the model for the calls. These are the percentage of calls over the districts. There are 23 districts in AP. And these are the ambulance counts for different districts. There are in total 690 ambulances, and here is the query to extract the data. Then average service time for each of the district. For Adilabad it is 92 minutes, for Anandpur it is 95 minutes, etc. So these are the average service time for the ambulances over the district. I have the simulation macro which I cannot show. Then this is the result. When I do a 50% reduction of the ambulance counts across district, we get zero waiting time. When it be 54% reduction of the ambulance counts, we get zero waiting time. But when we do a 55% reduction of the ambulance counts across districts, we get some 10 to the power minus 6, 3.71 into 10 to the power minus 6 waiting time, which is positive. So my suggestion was to do a 54% reduction in ambulance counts across the district. So still we will be, Hyderabad EMRI will be able to maintain the SLA. These are the actual counts of 690 ambulances, and these are the optimal counts of 317 ambulances. But surely this is a lighter, this is an emergency service. This is a life and death saving situation. So this was just a proposal. I will stop here. Thank you.